Problem number 7.1. It is given that x1, x2, x3, x4 up to xm are m non-zero orthogonal vectors. The dimension of vector space is spanned by 2m vectors, which is x1, x2 up to xm and minus x1 minus x2 up to minus xm is. We have four options: 2m, m plus 1, m, dependent on the choice of x1, x2, x3 up to xm. So it is given if m is non-zero and orthogonal vectors, then it is surely linearly independent, which means determinant value of x1, x2, x3 up to xm is non-zero. For example, we can take a matrix which is 1 0 0 0 1 0 0 0 1. So this is a 3 cross 3 identity matrix. It can be represented as x, y and z, and determinant of this matrix will be 1. Determinant of this matrix is non-zero. From x1, x2 up to xm we have m number of linearly independent vectors. So m are linearly independent. As problem has asked dimension of vector space spanned by 2m vectors. So we have 2m vectors as x1, x2 up to xm and minus x1 minus x2 up to minus xm. Take these vectors as separately. Now in 2m vectors, this is 2m vectors. Now in 2m vectors, m vectors are non-zero. Orthogonal vectors, we will take this as m and we get 2m. Next m vectors, which is this m vectors, are also non-zero orthogonal vectors, but remaining m vectors are depending on previous m vectors. So this m vector and this m vector, they are same, only difference is negative sign. Now we can take as an example as a bar and minus a bar, they both depend on each other, or we can take a cap and minus a cap, they both depend on each other. So when we are going to calculate rank of these matrices, then by applying operations, we get negative vectors as 0. By operation, we can say rank of M becomes M. So dimension of vector space spanned by the 2M vector are M only. So correct option is C, which is let us take example. Our problem is finished. Option C is correct. Let us take example 1 0 0 0 1 0 0 0 1, and we will take minus x1, minus x2 and minus x3. Minus x1 will become minus 1 0 0, minus x2 will become 0 minus 1 0, minus x3 will become 0 0 and minus 1. This is x1, this is x2 and this is x3. Now we apply operation. Will be c4 plus c1, c5 plus c2, c6 plus c3. So our matrix will become 1, and these are column operation. Now our matrix will become 0 0 0 0 1 0 0 0 1. Now we will apply operation, which will be 0 0 0 and here 0 0 0. Now finally we get 0 0 0. So rank will remain same. Rank will remain same, which is 3, but our matrix was 3 cross 6. Here dimension is 3. In problem, dimension is M.